Welcome to our Tech Talk on ground stations for satellite laser comm. I'm Edward Logue, CEO of Vision Engineering Solutions, or Vision for short. By satellite laser comm, we mean free space optical communication, or using a laser instead of a radio frequency to carry signals between Earth and satellites. Allow me a brief introduction to our company. Vision provides complete solutions for long-range optical pointing and tracking challenges, primarily for objects in flight and in orbit. We have a 10-year history of unique support to DoD RDT&E programs in areas such as high-energy laser weapons, laser-related research, tracking system upgrades, and laser deconfliction and safety systems. Key to our success are Vision's lead engineers who have worked together for over 20 years through hundreds of highly demanding optical tracking scenarios. Also key are Vision's software products for controlling both tracking systems and sensors. These products have been designed and tested by our lead engineers to meet their own exacting performance standards and are sold as part of tracker upgrade and refurbishment packages. The challenge we are addressing through this SBIR effort is alleviating bandwidth limitations and congestion for space downlinks in the radio frequency or RF spectrum. Data products from space have increased and improved and are driving up bandwidth requirements. Our solution is required to provide the following capabilities: a downlink of 1 gigabit per second from a LEO satellite, an uplink of 100 megabits per second to a LEO satellite, signal transmission and reception on one wavelength in the C-band of laser comm, which is between 1530 and 1565 nanometers, day and night operations, network connections via common protocols, and 2 years of operational life. Our goal is to add satellite laser comm capability to select bases, stations, and ships throughout the Navy and alleviate communication bandwidth and congestion issues. Communication bandwidth and congestion issues are not just Navy, government, or U.S. issues, they are global issues. NASA has stated that optical communications provide significant benefits for missions, including data rate increases of 10 to 100 times more than comparable radio frequency communication systems. Vision Engineering Solutions can provide fixed-site, transportable, and shipboard optical communication ground stations, or OGSs, for select Navy locations and units. Other services and government agencies as well can benefit from the increased bandwidth our OGS design will provide. Our OGS design comprises the following major components: the gimbal and telescope, the optical bench, and the transmit and beacon lasers. The gimbal very accurately points the OGS and tracks the satellite so the communication link can be established and maintained. The telescope receives the downlink and transmits the communication uplink. The optical bench includes the receiver and transmitter assemblies, along with a fast steering mirror, which helps keep the downlink in the center of the receiver. The transmit laser carries the uplink signal, and the beacon laser establishes the initial contact with the satellite. As a reminder, our solution is required to provide the following capabilities: a downlink of 1 gigabit per second from a LEO satellite, an uplink of 100 megabits per second to a LEO satellite, signal transmission and reception on one wavelength in the C-band of laser comm, day and night operations, network connections via common protocols, and 2 years of operational life. Vision's OGS is designed to meet these requirements and transmit and receive across the entire C-band of laser comm, accommodate all signal polarization states, incorporate a single or multiple C-band optical modems, and integrate with existing and future optical and/or RF ground networks. Supply chain issues have forced delays in our milestone projections. By 31 May of this year, we will achieve our first milestone, a manual tracking accuracy of 10 microradians RMS or better with the optical tracking subsystem. By 30 September of this year, we will achieve our final milestone with the system fully integrated into the customer's infrastructure, demonstrating the ability to search, track, and receive signals from required satellites, and achieving a tracking accuracy of 1 microradian RMS or better. The contract is fully funded, and a program of record has yet to be developed. There are several key advantages of laser comm over RF. Laser comm carries more data because the higher frequency of the carrier signal, terahertz versus gigahertz, provides higher modulation bandwidth. Laser comm provides more data for a given satellite size, weight, and power. The narrower beam of LaserCom provides more signal intensity for a given transmitted power and lower probabilities of detection, interception, interference, and jamming. Also, because optical frequencies are not regulated, LaserCom is much easier to scale capacity to meet increased communication requirements. The key advantage of the Vision OGS design is the ability for one OGS to communicate with multiple satellite networks. This advantage is enabled by the OGS's ability to transmit and receive across the entire C-band of wavelengths, to accommodate all signal polarization states, and to incorporate multiple optical modems. Additionally, this advantage provides higher utilization for the OGS, which will lower the cost per bit of data. To transition beyond our Phase 2 SBIR, we need a program of record and either the right optical modem provider or additional funding to develop a more versatile optical modem. We are looking for an advocate among program managers, satellite network operators and integrators, and ground network operators and integrators. What does the market say about LaserCom? Commercial bandwidth requirements are outpacing RF capabilities. Annual data downlinked from satellites will exceed 5 exabytes or 9 billion gigabits by 2024. There are multiple efforts underway to establish LaserCom ground networks by government and commercial organizations. For example, the Space Development Agency, the Binaric and SpaceLink team, and Genesis. The commercial LaserCom market is expected to pass $2 billion by 2028. Vision believes teaming directly with satellite network providers will give the most complete LaserCom solution for the customer. Thanks for listening to our Tech Talk. Now it's your turn to transmit, and we look forward to listening to you and helping you meet your LaserCom challenge. Here's how to contact us.